Good evening, everyone.
Hi there.
Good evening.
So, we are going to start the session. Dear authors and invited guests, welcome to the technical session 11A. Myself, Aarti Mohan, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 10th International Congress on Information and Communication Technology ICICT 2025. London, UK. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held on 18th in London, and the virtual event is being held through Zoom from 19th to 21st February 2025. I hope you all would be enjoying this knowledgeable and interactive session through the day. In this session, we have 6 presentations. Each presenter would be given 12 minutes for the presentation and 3 minutes for the question and answer session round. On 10 minutes, I'll raise a gentle reminder. There's another request to all the participants to stay connected with us till the closing remarks. If you have any sort of query or any update, you can write it to me in the chat box. Just before we get started with our session, I would like to introduce you all to the chair of this session. So we have Professor Bertram. He is an associate professor at Norof University College, Norway. We welcome you on board with us.
Thank you. Nice to be here with you.
Thank you. We have another session chair, Dr. Rupali Mahajan. She's currently working as an associate professor and head of data science department and associate dean, research and development at Vishwakarma Institute of Information Technology, Pune. She is highly accomplished professional with a strong background in computer science and engineering. She has contributed significantly to the field, holding a total of 18 patents. Her research interests span various domains, including machine learning, artificial intelligence, and deep learning. It's a pleasure to welcome you, ma'am, on board with us.
Thank you so much.
Before we get started with our session, I would request our respected session chairs to uh, give a opening remarks to all our participants who would be presenting in this session.
Since you asked me first, I'll go first. Good luck with the session, everyone. We are all here to learn, and all of us here have a passion for research and all things. So stay calm and enjoy the time in the sun. Have a good one.
Ma'am?
All the best to all the participants and looking forward for engaging and very insightful sessions. And all the best to all the participants. Thank you. You can please start the session.
Yeah, sure. So proceeding with our presentation, we have paper title, Exploring and Visualizing COVID-19 Trends in India, Vulnerabilities and Mitigation Strategies. We would like to have your presentation. Could you please start with your presentation?
Hello, everyone. Is my voice audible?
Yes.
Okay, thank you. Screen.
Yes, we can see your screen. Could you please start with your presentation?
Absolutely. Okay. Hello, everyone. I am Shoyamjit. So today I will be presenting my paper, Exploring and Visualizing COVID-19 Trends in India, Vulnerabilities and Mitigation Strategies. I am Shoyamjit Shah. I am currently a third-year PEC student in the Department of Computer Science and Engineering at Mississippi State University, which is in the United States of America. My other collaborators of this paper and essentially their co-authors as well, who are Dr. Kuntal Ghosh, who is an associate professor at the Machine Intelligence Unit at Indian Statistical Institute, and Dr. Gaurav Chatterjee, who is also an assistant professor at the Indian Statistical Institute. So to get started, this is our agenda for today. Yeah. So we are going to talk briefly about the motivation, our goal, background, data set, problem formulation, the results, the conclusion, the future scope, and the Q&A. Okay, so to get started with our paper, I would like to talk about a very apt quote, which is cited from the Leung CK et al. Paper, that without data, we are just another person with an opinion. And so we all need some kind of support with the data through which visualizations could be done. So our goal in this paper is that in the realm of big data analysis, visualization serves as a powerful tool to distill complex information into easily understandable representations. More significantly, in the context of COVID-19 epidemiological data, visualization plays a crucial role in conveying spatial and temporal trends of the pandemic. Our paper contributes to the empirical study of understanding the impact caused by the novel virus to the country by doing extensive explanatory data analysis of the data collected from Ministry of Health and Family Welfare of India. Our work contributes to the understanding that data visualization is prime in understanding public health problems and beyond, and taking necessary measures to curb the existing pandemic. So to give a brief background, during the COVID-19 pandemic, the significance of epidemiological data was pivotal to the researchers for striving to comprehend and combat the viral outbreak. While it was evident that the medical and clinical aspects of COVID-19 had collected substantial attention of the medical researchers, computer scientists have focused on the epidemiological dimensions of the disease. These insights, however, served as a direct guide to managing public health interventions, shaping policy decisions, and preparing varied responses to mitigate such future outbreaks. The integration of data science tools and techniques with epidemiological research underscores a collaborative approach to tackling global health challenges, highlighting the transformative potential of big data in addressing emergent health crises like the COVID-19 pandemic itself. So as for the data set of our experiment, we essentially used two CSV files for visualizing the data for COVID-19 infection and also the vaccination patterns. The files were uploaded in the Kaggle webpage, and it was uploaded by the researchers of the Indian Statistical Institute, Kolkata. I'm sorry, the Bangalore Center. The state level, the data was updated from the Ministry of Health and Family Welfare, which we used in our experiment. The infection and vaccination trends data was updated in the COVID-19 webpage that was continuously updated every day. This is the snapshot of the state level infections that we could see. So the various parameters are SNO is the serial number of days in an ascending order, the date, that is the timestamp, the time, state, confirmed number of cases, confirmed number of deaths, cured deaths, and so on. Okay. So we formulated actually 3 problem statements out of this data set. Number one is we intended to see the time series of COVID-19 infections across all states in India from March 2021 to August 2021, which was essentially the Delta period in India. Problem statement 2 is we try to visualize how the vaccine sites accommodation has changed over time with respect to the cessation of vaccination doses. And problem statement 3 was visualizing how, so this is just a use case, visualizing how the state of Odisha in India has made an exponential growth in installation of COVID-19 vaccination centers. Now, talking about the results, this is the first visualization that we did. That is the illustration of the time series of COVID-19 infections across all states in India from March 2021 to August 2021, which basically was the Delta period in India. So we see that during this time frame, there was a peak rise in COVID-19 infection cases across all the states in India. We see exponential rise of infection in almost all the states as illustrated in this figure. The region depicts the Delta period of COVID-19 in India from March 2021 to August 2021. It is also important to understand that the plot line becomes rigid after serial number 16,000 to 18,000, which means that which means that although the state governments in India declared that the infection rate has saturated, but in practicality, testing sessions for COVID-19 could not be further performed due to possibly unavailability of testing kits. So that's why the plot line gets rigid after the serial number of 16,000. And we see exponential numbers in confirmed cases because that's the number of cases for all the states. So it's a lot of people. Okay, so this is the second visualization we did, and that is visualizing how the vaccine sites accommodation has changed over the time with respect to the session of vaccination doses. This particular plot gives us an idea that the Ministry of Health and Family Welfare of India has exponentially increased the number of vaccination sites to conduct successful vaccination drives across all the states in India from this particular time period, that is from January 2021 to August 2021. The graphical plot line increases exponentially from 16 January of 2021, stating the successful vaccination doses for health workers in India, which included doctors, nurses, and other medical staff who directly dealt with the infected patients. Now, with the successful vaccination doses administered to the health workers, there was a concern for the senior citizens. So the senior citizens started getting the vaccination doses, and that's why it was started from 2nd March 2021, as we see in the graph. Then it was followed by the younger population. The decline in administering vaccination doses could be possibly because of DGCI intervention on Serum Institute of India. So Serum Institute of India is a company who made vaccination doses. Um, we believe this is the reason why there was like a decline in the supply of vaccination doses. Again, as of 9th August 2021, we see like the Ministry of Health and Family Welfare administered a total of 700,23047,716 doses to the Indian population. The administered vaccination doses to the population have helped to save millions of lives. And this is the visualization that we did just for the state of Orissa in India. And this was just to confirm our second figure, that it has made exponential growth in the installation of COVID-19 vaccination centers. This is for the time frame of 16 January 2021 to 9th August 2021. This perfectly aligns with the observation we made in the previous figure. So to conclude our experiment, India's vaccination campaign, one of the largest in the world, achieved significant milestones covering a substantial portion of the population. However, in terms of COVID-19 testing, possibly sufficient testing kits were not available over the country during the Delta period of the COVID-19 to test the individuals for a single day. Hence, the number of infections become saturated, as we see after July 2021. This study serves as a lesson for growing population nations that acting on time in accordance with a pandemic is necessary. The relevance of testing symptomatic individuals with regards to the disease as much as possible is crucial to assess the impact and make relatable measures to stop the spread of the virus. While challenges persisted, the collective response showcased the strength and unity of the nation. And as a future scope, we would say like future studies should show similar experiments in other developing countries so that the experiments could serve as test cases for future health workers and public health decision makers to make informed decisions to curb the spread of a future pandemic virus. I would like to answer any questions and answer anybody has.
Okay, nice presentation. My
Thank you.
question is, I think COVID-19 research is COVID-19 has reduced its impact, right, in 2024, 2025. So, are there any long-term health effects of COVID-19 that your research is addressing here?
So the long-term goal of this paper is to help the
No, not
public.
goals, not goals. Are
Mhm.
there any long-term health effects of COVID-19 that your research is addressing? That effects are still in 2025 from 2019. Any health
Um,
effects?
Not really. So basically, we try to assess only for the data that we had from January 2021 to uh, August 2021.
Yes.
So this was the data that was available at that point of time. So after that, basically, COVID-19 India.org webpage did not like update after 2022.
Uh,
So yeah, we could not do the experimentation after that time period, actually. Yeah.
Exactly, that is what I am asking. COVID-19 has reduced its impact in 2021 only. So,
Right, ma'am.
how relevant your research in 2025 on the COVID-19, or any symptoms or any health effect still that COVID-19 is showing in 2025? No problem, no issues. Okay.
So can I try to answer, ma'am?
Yeah, sure, please.
Yeah, sure. So actually, like we try to assess that like from the data that was available in 2021, like from January to August 2021, we tried to assess like how the infection infection spiked in that case, and how the government actually tackled that particular situation by administering doses. So as a long-term goal, like I believe the this study could be used as a test case um, to understand like more vaccination doses are required for like neutralizing the infection across all the states, and that uh, testing kits should be more available uh, so that more people
Okay, no problem. It's okay.
yeah
It's
could
okay.
be
No problem. I'm
tested.
asking
Yeah,
different thing. You are telling different thing. No problem. Okay. Thank you so much.
thank you.
Do we have time for one more question?
Yes, yes.
Okay. So my question is a bit less technical on the medical side. When you're conducting a study that's based on visualization, you might know that creating visualization, there's different things that you do with regards to visualization depending on who your audience is. So how did you decide what type of visualization to use, what color schemes, which actually chart types, how did you represent the data? How did you make these decisions, and who are your visualizations aimed at?
So our visualizations are mostly aimed for like public health workers, and like policy decision makers, could be like epidemiologists, and like we did this explanatory data analysis with the help of like R programming language, like with certain kind of libraries like ggplot and the libraries.
Okay, cool. Thank you. And then perhaps just a last follow-up question.
Right.
I'm sure the National Health Institute, or whatever the similar body is called in India, made visualizations during that time period.
Yeah.
How does your visualizations compare to what they did?
So, yeah, like there, like yes, that's a very good question. So there were certain visualization dashboards that were already at that time, um, but I believe like no visualization dashboard could basically give the idea that like more administration of doses are required, and no visualization dashboard actually just talked about the fact that the like infection spike, like why the infection spike is getting stringent or strict after a certain point of time. So apart from the visualization, I think the implications of those results are also very important, and I think that's what I worked on.
Okay, thank you very much.
Thank
Thank you
you.
so much, Dr. Bertram. Yeah.
Thank you so much for your presentation. Moving on to our next presentation, we have the paper title, Feedback Matching Neural Network for Time Series Forecasting. Dear presenter, could you please start with your presentation?
Okay, thank you. Good afternoon for you. My screen is clear with you?
Yes,
Yes.
My
we
screen,
we can see
Please
your
go
screen.
ahead. Yes, please go ahead.
okay. Today, inshallah, we will try together understand a new type of neural networks that depend on feed match algorithm, feedback matching algorithm. We'll start with the introduction, and then we will introduce the research question, literature review, proposed model, evaluation matrix, and result analysis and conclusion. First of all, of course, all of us know the importance of the forecasting in casual domain of time series forecasting at weather prediction and even energy management. We have many traditional methods like AR, ARAM, or exponential smoothing, but these methods struggle on the dependency of the variables, the dependent variables and independent variables. Also, we have the modern methods, the deep learning using neural network with multi-layers and like long and short-term memory examples, GURU. That's improve forecasting, but lack efficient pattern recognition. We have very far view for the actual time series. We convert the time series into a type of mathematical formula inside the neural networks. We suggest a new type of neural networks that combine between the two methods, the traditional method, which is the feedback matching algorithm, and the neural network, the deep learning, both of them in one model, and we call that model is the feedback matching neural networks. We integrate that so we can get the benefit of the two models, the traditional model and the modern models in one model. The research question, we try in this research answer the following questions. How can the feedback matching algorithm can be incorporated into deep learning? How we can convert the feedback matching algorithm into a deep learning neural networks? Can that feedback matching neural network outperform traditional forecasting models? What the advantage does pattern matching integration bring to the time series? We integrate the pattern matching of the time series, the previous time matching and pattern matching, and also the deep learning together. We make a deep literature review with the traditional methods, as we said, exponential, ARM, effective for linear trends, but struggle with complex temporal dependencies, as we said. Deep learning methods, of course, like long-term, short-term memory, GRU, recurrent neural network. Long-term depends, but lack of explanation, pattern recognition. There is no pattern recognition, just construct. We have learning, and then we have the neural network. Then we can use that neural network to prediction. We don't know how is the pattern inside. Current neural networks good detecting local pattern, but struggle with long-term forecasting. Feedback matching algorithm has the advantages of both methods. Recognize the heuristic repeating pattern to improve forecasting and expand الميثود الاكشوال ميثود الفيدباك ماتشنج algorithm into neural network structure. The proposed model, as we said, integrating the feedback matching algorithm into deep learning, suggest a model to convert the feedback matching algorithm into a neural network with the model consists the following layers as a neural network. The input layer, of course, sees the raw time series data. We have time series data. Of course, it is an incremental data. The time series, it's a start in time 0 and continue. And we receive that data, and the input layer will receive that data. The hidden layer will try to use the neural networks like a long-term, short-term memory or any neural network to find the pattern behind that neural network, behind that time series. Matching layer. Now, we already present our time series inside the neural network, and now we have matching layer that use the matching algorithm, depend on the feedback matching algorithm, and compare the current time segment with the past sequences. We have a selected segment which are used, and that matching layer try to find the most nearest pattern that happened at the past for the part we would like to forecast or predict its data. And after that, pass the result to the prediction layer. The prediction layer will forecast the values for the future after the matching layer has find the most important matching pattern. So we have the input encoding at the input layer, time series segmented into current observations. Pattern matching layer, search for similar past sequences. Prediction generation, future value predict based on the matching pattern. And training process, of course, we use the previous data that we have from the time series, and we train the model, use backtrack propagation and gradient descent for optimization. Loss function, mean square we use, and model trained using the Adam optimizer. This is a simple visualization image for the proposed neural network. We have the input layer, and we have the hidden layer, matching layer, and the prediction layer, which predict the output. To evaluate the performance at that method, we use the weighted absolute percentage error measure forecasting. We use the mean square error also, evaluating the deviations from the actual value. Root mean square error, determine model error sensitivity, and of course, when we compare, as we see, I will see now, as we will see the result now together, the proposed model, the feedback matching in neural network versus the other model, give compared result or sometimes better results. This is just presentation for all the used current neural networks. Compare with our neural network, the blue one, it's our network, and it shows better performance than the others at 12 training sheets. This is the training sheets, 12 training sheets, and this is the results for each one. The average, of course. You can see that here. Okay, this is our result. It is the smallest value for our model comparing with the other models on 12 sheets. Of course, our achieve lowest, as we say, weighted average percentage, okay, across all data sheets, outperform the other traditional or even the neural networks, the current used neural network, available neural networks that used in that sector of time series prediction and additional forecasting method. Pattern matching integrates significantly enhanced for forecasting accuracy. And this is the performance, as we said, when we compare the average of all these methods. As a conclusion, feedback matching neural network successfully integrate feedback matching algorithm and deep learning together and outperform conventional models in forecasting accuracy, demonstrate significant improvements in pattern recognition and time series prediction. As a future work, we can, inshallah, we continue testing that in neural network and try to use it in more applications. Extend to multi-variable. Now it is a single variable time series. We try to expand it to make it multi-variable, enhance real-time adaptability for streaming data. Thank you. If you have any questions.
Thank you. Thank you so much for your presentation. Ma'am, you have any questions?
No, ma'am.
So you have any questions?
Yes, I could possibly ask. I might have missed it in your presentation. The other results against which you contrasted your approach, did you generate these results yourself, or were they from an existing study to which you compared your results? Did you hear me? Hi there, are you back?
So yeah.
Did you manage to hear my question?
No, I don't receive your question. Sorry.
Okay.
I just have a problem with the internet at 1 minute.
Okay, no stress.
When I just finish it, happen.
Okay, no, no stress.
I'm sorry for that.
So, I might have missed it in the presentation, but the other results that you compared your approach to, were they taken from a previous study?
Yeah.
So,
We develop as a team. We already developed the feedback matching algorithm at the previous version at the 9th international conference. At the same conference, we already present the algorithm, and this year we try to convert that algorithm from a traditional algorithm into neural network.
okay. Yeah, because I was interested in knowing how optimized the other tests were, because you compared to quite a lot of other approaches. So it's interesting to know if you created those approaches yourself, because there's quite a few ways in which you could
We
have
already.
conducted the
Can
other tests as well.
you can return back to the previous to the 9th version. You can find our research, our paper. It's already published there.
Okay. No, I understand. Thank you.
Okay, thank you.
Thank you so much. Thank you for your presentation. Moving on to our next presentation. We have new 3D monocular object detection improvement for road and railway smart mobility. Dear presenter, could you please start with your presentation?
Yes, can you hear me?
Yeah. Yes.
Well, where can I share my screen? I don't. Let me. Finally, I found it. Can you see my screen?
Yes, we can.
Great. No, that's not. So I will present MAIV7 new 3D monocular detection improvement for railway and road smart mobility. My presentation will first focus on the context and objective, then on my methodology, then on the experimental results, and finally on the conclusion. So first of all, 3D monocular object detection, for those who do not know what it is, consists in detecting objects in 3D from a single 2D camera. So here we have a video example of 3D monocular object detection using our algorithm. And what is a point of 3D monocular object detection? Well, the reason why we are working on this is that unlike method which uses sensors like LiDARs or several cameras at once, 3D monocular object detection is cheaper and easier to train. But obviously it has drawbacks compared to other 3D object detection method because we do not have any additional information about depth and the model has to estimate it by itself. And our work in a greater context is part of a Giro project from Segula Technologies, which aims to develop an autonomous monorail platform and use a 3D object detection to detect obstacles on the railway on the road. And there have been lately a lot of progress in 2D object detection and in 3D object detection as well, but the both fields are kind of separated from each other. And as an example, in 2D object detection, there are new versions of YOLO that are frequently released, and we went from YOLO v5 to YOLO v12 in only a few years. So we wonder if whether this advancement can benefit 3D monocular object detection. So the main contribution is that we propose MAV7, an adaptation of YOLO 7 for 3D monocular object detection, which follows a similar work that has been made for YOLO v5, and we further differentiate ourselves from this work with a tailored loss function, the use of the SIM label assignment method, which was introduced by YOLO X, and we showed that the improvement made in 2D object detection from YOLO v5 to YOLO v7 can also translate in improvement in 3D monocular object detections. So first on method, we will talk about how to adapt a 2D detection method for 3D monocular object detection. Then we will explain our work on the loss function. Then we will focus on our evaluation protocol and the dataset configuration, which are used to evaluate how well our work. So to adapt to the detection method, which basically give only a two-dimensional bounding box around the object, we start from this 2D bounding box as a base, and we introduce additional predictions, which are the center offset position, the depth prediction, the dimension prediction, and the orientation prediction. I will explain what these are in the next slide. So the center offset position is that basically we assume that the 3D center of the object is also the center of its 3D bounding box. And so we predict an offset position between the center of the 2D bounding box and the center of the 3D bounding boxes. For the dimension prediction, we use the fact that dimension within the same object classes have a low variance. As an example, most trucks have approximately the same size. The same goes for car or pedestrians. And therefore, we use the average dimension of its object classes as a start, and then we use a variance to get the dimension estimation. And finally, for azimuth detection, we cannot directly predict the angle theta of the car because basically the camera only sees the angle alpha. So what we do is that we predict the angle alpha of the object, which is observed angle, and we retrieve the global orientation angle, which using the formula theta equal alpha plus arctan of x divided by z. Then we have a global loss function that is basically the sum of the different loss components. So loss total is equal to the 2D bounding box loss plus the 2D object loss, the class loss, the center offset loss, the depth offset loss, the dimension offset loss, on the orientation of set loss. Each of these boxes use different loss calculations. The bounding boxes use a complete intersection over union losses. L objects and L class use classification label smoothing, which were introduced by YOLO's V7, as well as binary post-entropy losses. Because these are too complicated to explain shortly, I have passed it, but the explanation of these losses are available in the YOLO V7 paper. For the 3D object prediction, we tested 3 loss functions: the smooth L1 loss, the mean absolute error, and the mean squared error. And we saw that when doing our experiment, we achieved better results with the smooth L1 loss, which is basically the combination of 2 usual loss functions, the L1 loss, which is linear, and the L2 losses. Now I will focus quickly on the dataset that we used. We used mostly 3 datasets. Kitty, which was published by the Karlsruhe Institute. It's a lot of wide images, but they are very small in terms of height. And it only has the time conditions. It got 3 object classes: car, pedestrian, and cyclist. We use a new synth dataset, which got a lot of images, both daytime and nighttime, and a very high quality of images. And it got 9 object classes, but in order to be able to compare it with a Kitty, we trimmed it down to only 3 classes, which are the same as the Kitty classes. We also used GTA, a synthetic dataset which was generated from the game GTA 5, which contain good quality images, both daytime and nighttime images. And the advantage of synthetic dataset is that also they look different from real life pictures. They provide perfect annotations because it's a simulation, and therefore we know the perfect position of every object. And this allows us to generate a lot of images for training sets, but of course there are still a difference from the real images. So we use different validation and training split for each dataset, where basically in order to avoid overfitting, we separate all the images that are used in training and all the images that are used to validate the training. And so we approximately do a 70%, 30% split. For the evaluation protocol, we use a regular 2D object detection metrics, which are the precision, the recall, the average precision at intersection of a union threshold of 50% and 85%. And we are completing this metrics with individual 3D detection metrics, the depth error, the center of theft, and score for dimensions and orientations, using different separate 3D metrics as a twofold uses because it grants us more insights on how dataset filtering, combination, normalization affect X prediction, and it allows us to adjust the model to focus on specific metrics. So the 2D object detection metrics are usual, and I won't go back on how they work, but here you can see the formulas of the different metrics for the 3D object detections. Now I will get on the experimental results. Firstly, in terms of qualitative results, we can see that the object detection framework works, and it accurately detects multiple vehicles, and it struggles with distant objects that are far from the camera, both due to the fact that they appear very small on the images, and because they also tend to not be labeled within the training dataset. It also struggles somewhat with the orientation of objects close to the camera. We can see that it works as well on the GTA dataset and on the new synth datasets. And the model can handle various weather and lightning conditions well, but we add still a somewhat reduced accuracy in nighttime images due to the dataset pairs, because most datasets contain much more daytime images than nighttime images. Now we move on the quantitative results, where we see the differences between YOLO V5 3D, the previous model that we compare ourselves to, and ME V7. And we see that globally, compared to YOLO V5 3D, our model is both faster and more accurate on most metrics, with the exception of the center score metrics. But the speed is very important for us because we want to use it in embedded systems. In terms of quantitative results, we also evaluate them on a 3D bounding box average precision. And so we see that we have a clear progresses. On best, our model on average better than the YOLO V5 3D models. And what is also important to note is that on ME V7 tiny models also get better results than the YOLO V5 3DL model, which means that there is absolutely no reason to keep using YOLO V5 3D.
Dear presenter,
Because it's-
sorry to interrupt. Could you please conclude your research?
Yes, I will quickly. And so we have higher accuracy in math metrics, and there are some drawbacks such as a lower performance in net offsets, slower inference time of large offsets. And we also concluded an ablation study to show the different impact of our different challenges, such as the baseline of moving from YOLO V5 to YOLO V7, the implementation of the CMOTA loss, the changes made to our losses, and the total sum of our changes. And so to conclude, we have successfully adapted YOLO V7 for 3D detection. We have a new loss function optimized for 3D detection. The CMOTA label assignment improved the accuracy of our model. And compared to YOLO V5 3D, ME V7 achieve higher accuracy and real-time performances. Thank you for listening to my presentation.
Actually, my question is, you have used 3 different types of data sets, right, for 3D molecular object detection. So what type of pre-processing techniques have you used in your result, in your project?
Well, the first pre-processing technique is that because we use a slightly different metrics, we add to some datasets only add grounded truth in terms of 3D bounding boxes, and we add to adapt the ground truths to instead give us the center offset, the dimensions, and the orientations. And so we add a lot of pre-processing to do on all the datasets in order to get them all on the ground truth format that we needed to train our model.
Okay, thank you. Nice presentation.
Thank you, ma'am. Thank you for your question. Thank you so much for your presentation. So you have any questions?
Maybe just a quick one. I'm always interested in the real world applications of things. And you mentioned you are working on the monorail application. So just for interest's sake, why are you following this avenue of research? Because a monorail seems like something where you have the capacity to do a fixed LiDAR type of installation. Do you see this as a cheaper alternative, which is always important, or do you see it as a secondary augmentation type system to a LiDAR based system?
Well, my work is part of a thesis which is funded by Segula Technologies. And basically, Segula Technology wants to focus on 3D monocular object detection because LiDARs are usually expensive and they really intend to drive the cost down as much as they can, if possible.
Thank you very much. Very interested to see how this pans out and to see how it's actually used. Nice presentation.
Thank you.
Thank you. Thank you so much for your presentation. Moving on to our next presentation. Sorry. We have The paper title, Optimizing V2X Communication for 6G, a summary of techniques and AI methods. Dear presenter, could you please start with your presentation?
Good morning, everyone. I am Ali Bilgassan, and I am pleased to present our work in optimizing V2X communication for CG in collaboration. This research is conducted at Poitiers University and Côte d'Azur University. Our motivation is to explore how artificial intelligence-driven optimization technique can enhance resource allocation and beamforming in CG-based V2X systems. Now, let me start with an overview of our work. This presentation provides an overview of V2X communication and the role of base station in managing network resources. We will discuss advanced techniques in resource allocation, beamforming, and artificial intelligence-driven optimization. The focus is on improving energy efficiency, requirement for future CG networks. To better understand the need for such optimization, let's take a closer look at the challenges CG introduces. CG will introduce terahertz and millimeter wave bands and enabling ultra-phase data rates. However, managing these resources efficiency is challenging. Artificial intelligence plays a crucial role in optimizing spectrum usage and improving energy efficiency. In V2X system, the complexity of vehicle mobility and power constraint in electric vehicle required intelligent adaptive solutions. To set the stage, let's briefly go over the fundamental of V2X communication. V2X communication includes several communication types: V2X vehicle to infrastructure, and more. Bus stations are central to managing these communications, handling channel access, frame structure, and signal transmission. Understanding these fundamentals is essential for optimizing network performance. Now let's see how we can efficiently allocate allocation with this framework. To ensure seamless V2X communication, various resource allocation methods are employed. Dynamic resource allocation adapts to traffic demand, traffic war, scheduling optimism, latency, and cooperative communication enhances connectivity. These techniques work together to improve efficiency and reduce network congestion. However, efficient signal transmission also depends on effective beamforming, which we'll discuss next. So beamforming is crucial for directing signal efficiency. We classify it into neural, passive, and active beams. Proper beams management, selection, tracking, alignment, and switching ensures stable connection despite the mobility of vehicles, improving both energy efficiency and network reliability. Since energy efficiency is major concern in CG, let's now explore the key metric used to evaluate it. Optimizing energy efficiency is crucial in V2X. Key metrics include minimizing interference, offloading data efficiency, and utilizing energy harvesting techniques. These strategies reduce power consumptions and enhance the sustainability of vehicle networks. To further enhance efficiency, artificial intelligence techniques have been introduced, which I will discuss next. So, artificial intelligence, particularly deep reinforcement learning, is a revolutionized V2X. Methods like deep learning, multi-agent learning, and proximal policy optimization enable intelligent decision-making. Additionally, techniques such as federation learning allow data centralized artificial intelligence training while preserving privacy. Artificial intelligence-driven optimization enhances both resource allocation and beamforming. However, implementing these solutions comes with challenge, which we now address. We challenge that despite these advancements, challenges remain. Scalability, latency, and integration complexity must be addressed. Future research must be addressed in future research in literature. So to summarize, integrating artificial intelligence into CGV2X systems enhances energy efficiency, while resource allocation and beamforming optimization sustainability. Our finding provide a foundation for the next generation vehicle communications. So thank you for your attention, and I welcome for any questions.
No questions from my side this time around.
Thank you, sir. Ma'am, you have any questions?
No question, ma'am. Please go ahead.
Okay. Moving on to our next presentation. We have parallel fitness course evaluation to improve training speed of NEAT algorithm using geo routines. Dear presenter, could you please start with your presentation? Yeah. Yeah, we can see your screen. You can start your presentation.
So actually, you see big screen or with caption behind? Below, I mean. Okay. So actually, sorry. My name is Yaroslav Milyanenko. I'm a researcher affiliated with Institute of Software System of National Academy of Science of Ukraine, and also I'm research director at Newground LLC. Here I would like to present my work, which is entitled Parallel Fitness Course Evaluation to Improve Training Speed of the NEAT Algorithm using Go routines. I would like to begin my presentation with beautiful citate reference to the Risto Mikulánin, who is godfather of neural evolution, about this method. So neural evolution is a computational modeling technique in which an artificial neural network architecture and or parameters are optimized through evolutionary computation. Much of current work in neural networks and artificial intelligence in general builds on gradient descent methods. This means learning a statistical model of a large training set. However, intelligent behavior in nature is instead learned through search process based on survival of the fittest in the evolutionary scale and reinforcement during the individual lifetime. Neural evolution offers a computational approach for constructing such behavior. Similar to biological evolution, it is the population-based search process. It provides a way to explore and the diverse sets of alternatives to discover stepping stones and evolutionary solutions that balance multiple objectives and can be surprising and creative. One of the popular and powerful among neural evolution algorithms is a neural evolution of augmented topologies, NEAT in short. The NEAT algorithm belongs to a class of evolutionary algorithms that apply natural evolution principles to train artificial neural networks. The training process with this algorithm begins with generating of random population of organisms that encode this basic structure of our artificial neural networks. And after that, our multiple evolutionary epochs, mutation operations are applied to each organism. And the most successful ones are selected for crossover Akari combination, resulting in formation of the next generation. And here we have some issue, because at the end of each epoch, we need to evaluate the fitness score of each organism in the population. Due to nature of the evolutional algorithms and tasks where it is applied, usually it involves simulation of very complex physical environments, which also may require some complex calculations, and which cannot be easily translated, for example, in NumPy programs, or represented as multiplication of matrices. So it's like running the simulation program, waiting for results, and then getting some score, and we should repeat this for each organism and population. So if this task is done sequentially, then it slow down all the process significantly. I mean, it's like step-by-step strategy. We have found the way, probably it's obvious, but anyway, how to optimize this. So to do this evaluation in parallel, and taking into account that our implementation of neuroevolution algorithm is already done in Go programming language, it was like natural to continue with inherent features of the Go programming language, which allow distributed computation and message passing. So actually, we developed some algorithm, the schema of algorithm you can see, but I will not go into particulars. It in more details is described in the paper presented to this presentation. But in general, so actually, as you can see, we at the end of the epoch, we go through each organism and population and start Go routine. So actually, Go routine, it's like separate process, but it's very lightweight process, so you can have thousands or hundreds of thousands of such processes in your machine. And also Go provide mechanism for inter-process communication, which called channels. So actually you need to serialize your data, put it into channel, then it will be executed in Go routine, and result will be returned back. After that, you collect all returned data and can do a further step of evolutionary algorithm, because now you have fitness scores for each organism in the population, and you can actually select the best one for reproduction, because evolutionary algorithm, usually you select the best one to produce next population. So actually, to evaluate results of our efforts, we selected two classic problems in dynamics in control theory. So the single pole balancing experiment and two pole balancing experiment. Single pole balancer is also called inverted pendulum. It's like unstable system when you have center of the mass positioned above the pivot point. So you have like some kind of pendulum which looks up, and the track behind it. I mean cart pole. And this physical part of this experiment simulated using Euler method with time step of 200 of seconds, 20 milliseconds. So actually our goal is to produce control neural network, which as input receives position of the track of the cart on the track, velocity, and angle of the pole, and angular velocity of the pole, and it produces force which apply to the center of the mass of the card with equal amplitude but in different direction. It's called band controller in the area. So successful balancing takes about 1.5 million steps to be completed. So if it was balanced for this number of steps, then we decide that it's okay. Result of this single pole balancing presented in the table. So we have executed it for sequential evaluation, no difference. And hello, do you hear me?
You froze for a second.
I froze, but I was on this slide, yes? Single pole balancing results, yes? Or before it?
It's perfect. Now it's this one.
Okay. So actually, as you can see, for single pole balancing, there is almost no difference between sequential and parallel evaluation. And this can be explained by the fact that mathematics is very fast for this simulation. So actually, costs to parallelize this estimation just negate the speed gains achieved. So actually, after that, we move to the second experiment, which actually more computationally intensive to simulate, and it is based on Runge-Kudde first order method of differential approximation. So in this case, we have a card with two poles, and our goal is to balance this card that both poles just stay as vertical as possible and does not overthrow. So we try to evolve control artificial neural networks, which will receive some input parameters such as before. Its position of the card, its velocity of the card, and then we have two poles. So we need to have two angles and two angular velocities. The control output is also a band controller. So we just apply force with the same amplitude but in different directions. Because this is a bit more computationally intensive, we decided that 100 steps it would be enough to assume that it's okay.
Dear
And
presenter, sorry to interrupt. You have 2 more minutes to just conclude your research.
yeah, okay. So actually, as we can see, in double pole balancing experiment, we have a huge improvement completed to sequential. So it's like if we take average trial time, it would be like 3 times faster. If we take average epoch time, it would be like 6 times faster. So actually, returning the results which we achieved shows significant improvements in training speed if a problem is complex enough in simulation. If a problem is simple, then probably there is no difference and you can just not spend your efforts on trying to implement to parallelize something, but most real-time problems is actually really hard to be simulated mathematically. And so this gives us hope that applying such methodology can improve acceptance of neat algorithm for different tasks in real time. So actually, right now mainstream is deep learning, but neuroevolution also has its strengths. For example, it can be applied when there is too little training data because it does not build a statistical model. It rather try to find intricacies inside data which it already have. And also because it starts with very simple structure of neural networks and develop it to more complex, usually the structure which we get at the end is really optimal. So it has minimal amount of nodes and connections between them, and as a result, it's very energy efficient, which allows to have it in resource-constrained devices like robots, unmanned vehicles, etc. So that's it from my side. Thank you.
Thank you so much for your presentation. Do we have any questions?
No questions, ma'am, from my side.
Okay.
Yes, I'll go. So firstly, possibly just a comment. I really enjoyed this. Evolutionary algorithms are one of the things I actually really enjoy working with. And also, thank you. I've never actually played around with Go. I'm more still R and Python and then traditional programming languages. So from my side, it would be interesting to know if I had to implement something in Go, whether it's an evolutionary algorithm or otherwise. I've seen or heard that Go is very lightweight, which is obviously the reason you've gone with this, and it allows for true parallelism, which you can't really do with Python or Java or C# threads, etc. But for interest's sake, have you tried running it in Python to see if you try to parallelize it using traditional threads? How much of a performance difference does it make?
Yeah, actually, I have not tried it with this Python. I mean, in this specific task, but actually, I was comparing Python implementations with my Go implementation in different, not parallel, but in sequential tasks. And actually, Go is much faster because uh, this algorithm is mostly like loop in the loop. You see, Python is not very good with this.
Yeah.
Python good when you have NumPy, SciPy underneath, and there is a matrix multiplication done in BLAS or CoBLAS, but not like in usual constructive programming language. But with Go, we have almost performance like C, but it's
Oh,
much
really?
yeah.
Oh, great stuff. Yes, I have to thank you. Thanks. You've inspired me. I'll go and investigate Go a little bit. So thanks for that.
Yeah, actually, it's open source that you can find it on GitHub. In my paper, I have provided a link to the source code, so you can even play with it. if
Awesome.
you like.
Thanks. No, I definitely will. Thank you. Nice presentation.
Thank you.
Thank
Yeah,
you. Thank you
thank
so
you.
much for your presentation. Thank you for your questions. Moving on to our next presentation. We have a paper title, Strategies for Culturally Responsive AI in Education, Mitigating Bias and Enhancing Student Outcomes. Dear presenter, could you please start with your presentation? I repeat, Strategies for Culturally Responsive AI in Education, Mitigating Bias and Enhancing Student Outcomes.
Thank you. Can you see my screen?
Not yet. Could you please share right? Yeah. Yes, we can see your presentation. Could you please start with your presentation?
All right. Good evening. Thank you to everyone. My name is Dr. Kayode Itadi from the Department of Computer Sciences, Val University of Technology. And I have as my collaborators Professor Aneke and Professor Tranos Zuva, also from the same department. All right, our topic is strategies for culturally responsive AI in education, mitigating bias and enhancing student outcomes. And in the next few minutes, we're going through these timelines. Just to start with, AI is making impact and reshaping various aspects of society, influencing industries, personal lifestyles, global economics. However, concerns exist regarding cultural responsiveness and AI systems. And just as a background, this study mainly from the context of South Africa as a developing nation. We understand that AI is influencing our societies. Like, for example, in finances, we have records of it automating processes. In communications and entertainment, we have the deepfake technologies we have it generating AI context. But for South Africa, which is a developing nations of more than 40 million people, due to the injustices and inequalities of the past, it is culturally aware and conscious in every policies decision making, recognizing the fact that there must be equity, there must be inclusiveness. Yeah, so in part of their national strategy and national infrastructure for year 2030, it understands that education is one of the key to address these injustices. And with the rise of all these artificial intelligence changes in technologies, it is actually as a flag to say we need to be aware of this cultural responsiveness in its development of its AI systems, which is one of the motivations for the studies to ensure that AI education is inclusive and equitable. And so with that background, just as I stated that it is reflecting in different areas in education, we understand that AI is affecting the opportunities, part of the personalized learning experiences. It's enhancing student engagement. It's providing access to quality education. However, the challenges are biases in AI algorithms, the lack of cultural inclusivity, and the risk of deepening educational inequalities. Further on, why do we then need this cultural responsiveness in AI? Because we understand that it may reinforce stereotypes and systemic biases. When we neglect cultural diversity, we can alienate some certain students. And we also found that the literatures are focusing more on the technical aspect of this technology and neglecting social and cultural implications. And there is a need for us to embed cultural inclusivity in educational tools. And so the aim is just to explore this study, to explore strategies to enhance this cultural sensitivity and to mitigate biases in AI-powered educational content, considering these objectives. We also consider this philosophical foundation just to put like a theoretical lens and for applicability of these studies to real world examples. And one of those that we felt could relate was social constructivism, that knowledge is shaped by social and cultural context, about a critical theory examining power structures and challenges, and the ethics of care, trying to introduce empathies and responsiveness in AI development. So our literature is focused on the methodology as a literature review approach from this data studies, focusing on these areas: bias mitigation, cultural sensitivity, and the need for responsible AI development in education. So part of our findings is that AI, we understand that it can personalize learning, it can address educational gaps. It's actually giving a lot of students who don't have access to this, access to education. It's actually filling up these gaps. However, we also understand that this bias can perpetuate inequalities. It can disadvantage underrepresented groups. It can exclude marginalized students from quality education, and this digital device can worsen disparities in AI-driven learning. Also, part of the findings are the sources of biases that could be introduced in developing these AI-driven powered content, educational content, data biases, which are when the algorithms are trained on non-representative data sets, it excludes some certain type of people. The algorithm bias introduces subjective choices in model development, representation bias, inaccurate or stereotypical portions, the interaction bias, and bias amplifications. So these are the different types of bias that we identified could be introduced if it is not carefully developed. Also, we also found that examples of AI bias in education, one of the notable examples from literature is this automated essay scoring, where we found that the system was actually disproportionately penalizing some certain specific people because of the cultural variations and the accents, and so alienating some specific set of people. We also found that there were gender bias in student counseling, in the sense that the male students were more being pivoted towards STEM education, engineering, and the likes, while it encouraging females to go pivot towards education, teaching, nursing. So it is actually introducing bias in gender bias, and another system during COVID-19, where in the UK there was actually a protest where students from a specific representation of people, it failed them because of historical belief that this set of students from this economic economic region, they don't naturally perform, while it passed some students from a specific region. So these are examples of the need for us to be conscious and aware that when designing these artificial intelligence educational tools, we need to be we need to be aware of those cultural variations, and so that we don't exclude the needs of others. And one of the strategies were recommended for this cultural sensitivity is to implement diverse and representative training data sets. We should design AI model with ethical and cultural consideration. We must involve educators, students, cultural experts in AI development, and there must be continuous monitoring and auditing of AI tools for bias. And in conclusion, AI has the potential to improve educational access, but it must be inclusive, it must be representative, it must carry everyone along, and addressing cultural bias in AI is essential for equitable learning outcomes. And we recommend, just like in the previous slides, diverse data sets in AI training. We must embed cultural sensitivity, and we must implement policy guidelines for responsible AI in education. And that is it from me. If there are any questions.
Thank you. Thank you so much for your presentation. Any questions?
Yeah, sure, I'll go. Do you believe that the biases in the data sets, they are culturally driven? I mean, that's been shown worldwide. Do you believe that it's possible, say, for instance, to have a data set that's representative for a country? Or do you think they would have to be regional data sets because of the vast differences, even in small regions, with regards to cultural differences? How granular do you think do these kinds of specific training sets have to be? Or can you generalize across regions?
Okay, thank you. That's a nice question. And you said, do I believe? So I think it will be subjective, but in reality, I don't believe that we would have an inclusive data set. We just have a scenario where DeepSeek and OpenAI, so where some certain questions were asked DeepSeek and it was telling us. So I also learned that India has also pushed that in the next 8 to 10 months, so there is this race for artificial intelligence. It means that there will be regional. So most of all this AI development will be region specific to suit, and then each of them will be at the need. So in terms of granularity, it won't be granular, but there will be regions to suit the context specific. So it's also a kind of awareness for different regions to come up and develop to suit their respective context, such that when I go in the Chinese region, I am carried along in different regions. So I think that's my response. I don't know if that is sufficient.
Yeah, that's sufficient. And I like that you picked up that I use the term belief because in many cases, I mean, this type of thing, you'd have to back it up. And we are so early on in the days with we standing on the forefront of where tools such as the large learning models, etc., can sort of emancipate education, because this is what we're looking for. We want to be able to provide education that is geared to the people in their region, and we want to be able to adjust things so that we use examples that someone in a specific region can relate to. And at the moment, it's quite difficult to do. And I'm sure there'll be more studies like this coming out in future. And it's the belief of grassroots researchers that are actually going to drive this. So thank you for picking that up, and it was a good answer.
Thank you.
Thank you. Thank you so much for your presentation. Thank you so for your question. Ma'am, you have any questions? Okay.
Hello. No, ma'am. No, ma'am. Please go ahead.
Okay.
A
Okay.
nice presentation.
Yeah, thank you, ma'am. So this brings us to the end of our presentations. So I would request our respected session chairs to provide a valuable feedback and share their insights regarding the presentations that we have covered in this session.
I'll go first.
Yeah.
I don't know, Dr. Marjan, you can go first.
No. Please, you go ahead.
Okay, thank you. I must say I enjoyed the session quite a lot. I find it really encouraging to see, even in today's age where we are so inundated with in the media with everything is large language model based, that we still get grassroots studies that try and use the variety of tools that we have with regards to machine learning and AI and related tools to try and make grassroots research contributions that in most of these cases actually aim at making a change in society. So thank you so much for a few very good presentations. I enjoyed being part of this session, and thank you for ending my day on a high, because it's around about, it's 8 o'clock-ish where I am at this moment. So you are ending my day at a high. So thank you for that.
Yeah. Thank you so much for your valuable feedback, ma'am.
Thank you so much. I extend my sincere appreciation to all the participants and panelists also. Special thanks to the organizing team and technical support for the execution of this session. And we enjoyed all the sessions, all the presentations. All presentations were very interesting and insightful. Thank you so much.
Thank you, ma'am. Thank you so much for your valuable feedback. So I sincerely thank all our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, would like to thank you for the support during this 10th version and all the previous 9 versions of the conference. We would be happy to have you all in the 11th version as well in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to Springer. The publication would be live within 6 months. Kindly cooperate with the team of ICICT. I would like to thank our session chairs for sharing the session. Thank you, sir, for making your valuable presence. And thank you, ma'am, for making your valuable presence too. A token of appreciation to our chair on behalf of Team ICICT 2025 and Global Knowledge Research Partners, Foundation and Partners. Thank you so much, our respected session chairs, for making their valuable presence and sharing the valuable feedback with all our participants. So I kindly request all of you to please switch on your camera so that we can have a quick snapshot of this virtual conference. I would request every participant to please switch on your cameras. Thank you. Thank you so much, everyone. Stay safe and take care. Bye.
Thank you, everyone.
Thank you so much. Thank you,
Bye-bye.
Bertram. Yeah,
Thank you.
thanks. Bye.